Hello, right. So, hello everyone. My name is Farouk. I'm a final year mechanical engineering student, and I'm just starting to upload videos on this channel again. And the idea behind it is that I'm going to create some videos for you guys on ANSYS or any other stuff, just like paper on paper, or solving some questions or whatever it is. And it's just so I can sort of teach you some stuff and you teach me some stuff. I'm going to make mistakes, obviously. Everybody makes mistakes, fundamental mistakes, big mistakes, small mistakes. Yeah, I'm not worried about that. But hopefully, if I make mistakes, you guys do let me know in the comments what I'm doing wrong and how I can improve it. And obviously, that'll be helpful for me. It will make me make better videos, and then obviously, I'm able to sort of teach more, teach better. And yeah, it's a two-way process. So I teach you, you guys teach me, and that's the whole purpose behind me start making these videos. So yeah, let's just get started on ANSYS. So you need to create a little video on ANSYS Fluent. Just click it, drag it, drop it. Go in geometry, double click. Now we are in ANSYS space claim. So we're just going to create a little box here. Okay. 100, and then I want to go on the next. Say 300 mil. Okay. So now I'm just gonna that, so you can get it like that, so you get like a 3D shape. And then, but you don't need to do it. Click anything. Just click Escape on your keyboard, and so it goes off it. Now you can just click off this. You don't need to save anything. Click off it. It's your meshes inside, your geometry is inside here now. So we just double click on here. You open this up. It takes a bit of time just to load the geometry and stuff. ANSYS is quite slow generally, unless you have like really supercomputer or something. But yeah, it takes its time usually. So here's our geometry now. I'm just gonna generate initial mesh, just see how it looks like initially. It's actually quite structured, quite nice. So just make it a bit more denser. Let's generate this. I'm not allowed to exceed 512,000 elements because I have an ANSYS academic license, which you can download yourself, by the way, for free from ANSYS website. There's also a course that on the download page is a course from Cornell University, United States, on ANSYS, and they take you through the basics, and then obviously teach you a lot more. The professors out there who teaches you everything about ANSYS. I've started the course myself. I'm not finished it yet, so I'm a complete beginner myself with ANSYS. But I just thought, why not give it a go? Just create a few videos, and then obviously I can get some feedback from people. It'll help me to improve. And so here's our mesh. Let's go inside down. You can see got 30,000 elements. It's fine. It's quite dense to me anyway. So we're going to use these features at the top. Select the edge. Create our name selections. So you can right click, create name selections, inlet, and then we're gonna go here, right click, name selection, outlet, and then we're going to click on this, press Control on your keyboard, and then select this edge, right click, create name selection, wall, And just to see your name selections, you can go on here. Here's your inlet, there's your outlet, and there's your two walls. You can go off this now. You can, this is me just to like refresh it, update. Okay, so now you go setup, double click. The window pops up here. Now it just tells you that processing stuff, double precision, the battery low. Let's put the battery inside. Double precision. If you got more processors, you can just add a more processor if you want. It just gets simulation speed quicker. So you're gonna click start now. So now we're in ANSYS setup. We set up your problem and enter your boundary condition and stuff whatnot. Okay, this is our problem, inlet, outlet. Pressure base, density base. Pressure base is used for where your density is constant, or you're assuming it to be constant. So you use a pressure base solver. Density base solver is used for analysis where your density is changing, like shock. If you got jet engines, you're trying to simulate a jet engine where obviously if you go above Mach 1 speed of sound, the fluid will obviously compress, density goes up, so you can have different densities in your model, so you need to use a density based solver. But yeah, if you go on Google pressure based solver ANSYS, you can actually get a page, answers written on it. It's like an ANSYS handbook where it explains everything about pressure based density, all the methods behind it and stuff. Steady simulation, not transient. That would just take too much time, and I haven't got the space, I think, on computer. So we're just gonna go on materials and see what we're actually doing. It's air simulating, aluminium, I think. Yeah. Boundary condition. Double click this. Double click the inlet. Should pop up a window now. Here we go. Enter velocity of, let's say, 10 meters per second. Should be fine. In pressure, wall, yes. Dynamic. No, we don't need to do that. Of that. Go on methods. We need second order, and second order because it gives you more accuracy. You can set this up again on Google, but it's just theory. That we need to go over at the moment. Go on monitors, go on residuals, and you're just going to improve this and make this number a bit smaller so you can get a better result. Okay. Okay. I'm gonna go on initialization, standard, compute from inlet, initialize. That's done that. Now we go on run calculation. We go on number of iteration. 1,000 is a good number to put in usually. Calculate. Residual plots. Wait. Should this converge like 60 or something, maybe 70. Okay. Converge that 64. Okay. So now we can go on graphics. We can view our contours results. So you're gonna go on velocity contour. Gonna go on compute and display and close this. And here's our velocity contour. As you can see, we have 10.3 meters per second in the center. So we had an initial velocity of 10 meters per second, and then we have 0 near the walls because due to boundary layer theory, obviously you're gonna have 0 velocity near the walls, and then as you come in and inside the geometry, the velocity is increasing, and that's the plot there. You can see if you can view pressure. So the velocity here is higher, so the pressure we expect to be lower here, and velocity there is lower, so we expect the pressure to go up as we get near and near walls. Let's see if that's actually true. Compute, display, and it so is. We got obviously we have zero pressure, incredibly low pressure in the center, and we get high pressure near the walls. If someone can really explain to me why this came up like that, because I would be expecting the pressure contour plot to look similar to the velocity, but just obviously the colors represent different things. Zero at the center, or lower at the center, higher at the wall edges. But yeah, that's there, and maybe it's quite high pressure here due to obviously the velocity just entering right now. So maybe I think maybe it's to do with the fully developed or not fully developed flow. Maybe someone could elaborate on this in the comments, and that would be nice for me. But yeah, view our vector plots. Start. It's going to be too much, so you can skip a few vectors just to see it better. Compute, display. Here we go. So our vectors, you can see. And yeah, it's just cool thing. If you did transit, you can use animations. Animate your result. I think you can still animate it. Just go back and do a quick one before I run out of the time. So save changes, yes. If I open up in CFD post processor, open it in here. Yep, so if I just go on streamlines, yep, streamline 1, it's from inlet, say 100, velocity, and apply. Here it is. So now if I just click on that, zoom out a little bit, and you can see how so same thing as the velocity control as you see before. But what you can do here is you can actually animate something a little bit. So you can do a bit slower. Here we go. So you got faster velocity at the center, slower and then near the walls, and just proves the theory of boundary layer and stuff. You can research about boundary layer theories. Interesting topic area. But yeah, I'll actually recommend a book in the description or somewhere on boundary layer theory. But yeah, thank you so much for watching, and if you got any suggestions about future videos or how I can improve my own knowledge about CFD and fluid dynamics, please do recommend me some books or online websites or articles and stuff. It will be really, really helpful. But I hope you liked the video. It's just my initial videos. I'm a beginner myself, so hopefully I'm going to improve with time, and the more videos I make, hopefully I'll improve with software and making videos. But thank you for watching. Thank you so much.